So in section 2.2 math analysis, we are going to be investigating more about functions, and this is just a quick graph of a very random function that I've created for you, and we are just going to go through these questions so you can see the types of things that we're going to be looking at in section 2.2. This is the first part of 2.2, and then the second part of 2.2 will be a separate video about piecewise functions. So let's get started and let's look at the domain of function f. So the first thing you need to keep in mind is that domain is read from the left to the right, from the left to the right. So as we go through this function from the left to the right, also keeping in mind that domain has everything to do with the x-axis and the x input values. So if we're after the domain here, we see that this graph is going to the left forever. So we're going to do our domain and range. We're going to do them in interval notation. So our domain has no leftmost point, so we are going to say that it starts at negative infinity. But as we go from left to right, we see that we do have a rightmost point. Notice that that is a closed circle, so that is the end of the function. Therefore, it is the end of the domain, and that particular point is at 9, -4. So our domain is going to be stopping at 9 inclusively. So that's the domain. Domain, all about left to right. Next is the range. The range is all about bottom to top. Bottom to top. We want to start at the bottom and go up. The range, of course, is all about the y's, the range, the output, the dependent variable. So bottom to top, once again, this particular function is going down forever. So even though this point is lower over here, this arrow is going down forever. So we're going to say that our range is also going to start at negative infinity, but our range does have a top value here. Our maximum value is going to be found at this particular point. The coordinates of this point are 3, 7. Remember, the range is all about the y. The range goes up to and includes 7. Now, let's look for the zeros. The zeros of the function. The zeros of the function, zeros are synonymous with x-intercepts. So we've got 2 x-intercepts, and I'll even write that in so you'll be reminded. The x-intercepts, or the zeros of the function, are found at x equals -8 and x equals +7. Notice that I just listed those in a roster notation, not an interval. There are exactly 2 of them, and anytime that we're going to create a list, it's going to be in a roster notation. Intervals of increase. Intervals of increase. So let's highlight where the function is increasing. So once again, intervals of increasing and decreasing, everything is always about left to right. So we are increasing on the function here and there. So those are our 2 intervals where our function is increasing. Now, one thing to keep in mind is that intervals of increasing, decreasing, and constant, they are always bound with parentheses. So it looks to me, remember, this is going down and to the left forever. So it looks to me like we are increasing in the interval from negative infinity to -6. Once again, always bound by increase, or always bound by parentheses when we're talking increasing, decreasing, or constant. We pick it up again. Remember, left to right, we're talking about the domain. We're going to increase again from -2, from here all the way to here. So another interval, so we can say union, -2 to 3, close the parentheses. These are the 2 intervals where the function is increasing. Now, where is the function decreasing? Well, the function is decreasing only here. So we're only decreasing in one interval. Everything else is increasing because increasing, decreasing, and constant, read from the left to the right. So we have one interval where it's decreasing. Once again, intervals of increasing, decreasing, and constant, always bound with parentheses. So we are going to be decreasing from 3 to 9. And let's talk for just a second about why we use parentheses. Because if we look at that point in particular, which we will say is the max point, so we do have an absolute max here. So an absolute max at x equals 3, or we could say the point 37. That's the highest possible value for the function. At that particular point, the function is neither increasing nor decreasing. So this is actually also called a turning point or an inflection point. So the function is not doing neither increasing nor decreasing there. That is why we always bind it with parentheses. And then, of course, we do have a part of the function where it is constant. In this interval, the function is not increasing nor decreasing. It is constant. So we would say from -6 to -2, neither increasing nor decreasing, it is constant. So if we have an absolute max at 3.7, do we have a min? We do have a relative minimum value right here. So we could say this is a relative min, and that relative min is at x equals 9, or the point 9, -4. So that is a lot of questions about this graph. We do have a few more, so let me get my handy-dandy technologically advanced paper right up here. So let's answer a couple more questions here. So the next one says, what are the values of x where the function is greater than or equal to 0? So once again, we're talking values of x, we're talking left to right. We are going to answer in the form of an interval. So the function is fully above the x-axis from here to there. So this is going to be our interval. This is going to be the interval where what values of x make a function greater than or equal to 0. So we are going to include this point because it's or equal to 0. We will include this point as well because it's or equal to 0. So our function is greater than 0 between -8 and +7 inclusive. Remember, it says greater than or equal to 0. That's why it's going to be inclusive there. Next, the values for x where f of x is strictly less than 0. So that is going to be everything here and everything here. Now remember, that is an arrow, that is a closed circle. So that's going to give us two different ends here. So if we're talking about this interval left to right, where are the values of x less than 0, since this is going down forever, the first part is going to be -∞ up to -8 parenthesis. Remember, we included the -8 when it was or equal to 0. Therefore, we can't include it twice because it's not equal to 0 here. It's strictly less than 0. We also want to include the other interval, so we're going to say union, and then we have a function that is less than 0 from here to there. And this one is already covered because it's equal to 0, so we will not include it. We will show that with a parenthesis. Remember, the parenthesis does not show inclusion. And then it goes to 9 and stops at 9. Therefore, we will include it at 9 because that is a closed circle, not not a open one. Lastly, values of x where f of x equals 3. Now, where does the function equals 3? The function equals 3 here and there. So we need to show that. And we are going to have to give a bit of an estimate over here, and that's okay. We'll call this, if we wanted to label the location of that point, we're going to estimate and we're going to say that it is 5.2, whoop, that should have been a comma, 5.2 comma 3. So 5.2 comma 3, that'll be the location of that point for the sake of answering this question. But what I really want to talk about is this. So this is going to be an interval because there are infinitely many values that exist in between -6 and -2. So we don't want to lose any of them. So if we're asking for the values of x where f of x is equal to 3, it's going to be this interval, and remember the interval is always talking left to right in terms of the domain values. So this is going to be inclusive -6 to -2, and then union, and then we're going to introduce a roster notation because this is not going to be an interval. This is a single value, which we said is x equals 5.2. So the interval from -6 to -2, so this where the graph is constant at f of x equals 3, and then f of x also equals 3 here, which we are saying is 5.2. So that's why it's in a roster notation. An interval in union with a roster. A roster is a list. An interval is an infinite amount of values. We are going to see more problems like that in your homework.